Okay, let's look at what pipe friction loss is. So, first off, how do we know that it's there? Well, you can read a pressure drop. Here's a little more than 5 to a little less than 5. And as an example, with 20 GPM flowing to the right through this pipe. Okay, and we know that we're losing pressure, and there's something causing that, and it's called friction. Okay, and so when there's flow in a pipe, you get friction. What causes it? It's caused by fluid velocity. When the fluid is moving through the pipe, it rubs against the edge is one simple way of thinking of it, and it kind of bumps into itself and has a little bit of hard time moving through really easily. So we know that fluid velocity causes friction loss. And we also know that the more velocity there is, the more pressure drop we have in a certain length of pipe. So fluid velocity is a big deal. Okay? So how do we control fluid velocity? Well, we do it with pipe size. So if I have a certain velocity in my pipe at 20 GPM, if I get a bigger pipe with 20 GPM, the velocity will be smaller. Okay, so bigger pipe, lower velocity. Lower velocity means lower friction. So that's how we control it. If we need less friction, we put in a bigger pipe. So let's see how we can use this now. Okay, there are friction loss tables. Friction is a little bit like stress in that in many cases it always acts the same. So if I have a pipe that's a certain size with a certain flow rate going through it and it's a certain smoothness or roughness, I'm going to get the same friction loss in every 100 feet of pipe. So if I know the flow rate and I know how much friction loss in each 100 foot of pipe I can handle, that's your available friction loss per 100 feet of pipe, I can find the right pipe size. So I would pick my GPM, my gallons per minute, my flow rate, and draw a line across. And then I would find my available friction loss down on the bottom, and I would draw a line up. And where they meet is the ideal pipe size. And of course, that's often not there is no, like in this case, it would be maybe a little bit above 2.5. There is no 2 5/8 pipe size, so you would go to the next biggest one, 3 inch. Okay. Now there is a little bit about maximum velocity and all that kind of stuff, but that's just a note for us that you can always pick a bigger pipe size and lose less friction. So let's go through that one more time. If I know the flow rate, 100 GPM, and I know my friction loss available in this example, 2 psi per foot of pipe, I go across on the flow rate. There's my water, gallons per minute. There's my 100. So I draw a line straight across. And I find my friction loss on the bottom. And I draw straight up. So there's my 2 psi per 100 foot. And I draw straight up. And where they cross is my ideal size. So I have to go up to the next biggest pipe, which is 3 inches. So that's how we read one of these friction loss pipes and charts and pick the correct pipe size for my job.